This is for mathematical methods. It's the VCAA 2019 exam 2, question 4, the probability question, and bits of it that relate to 2020. So we have the bird wing of the Lorenz and its butterfly. Okay. The wingspans are normally distributed, mean of 14.1, standard deviation of 2.1. 14.1, standard deviation of 2.1. One of the probabilities is the random selected bird wing butterfly has a span between 16 and 18. So if X is normally distributed, 14.1, 2.1 squared, then we want the probability that X goes from 16 to 18. So distribution continuous, CDF, lower is 16, upper is 18, 2.1 is the standard deviation, and 14.1 is the mean, and we're looking at 0.51150, and we're going to 4 decimal places, 0.5115. Okay, E, the birdwing butterfly is considered to be very small if it's in the smallest 5% of all bird wings. So I'm looking for the smallest 5%. Find the greatest possible wingspan, so I'm looking for this value. So I'm going to do an inverse normal. So distribution inverse normal CDF. It is left, probability is 0.05. The 2.1 is the standard deviation and 14.1 is the mean. So 10.6458, 1 decimal place is 10.6 centimetres is what we're looking for. Every year they conduct a sample of 36, and if it's very large it's considered greater than 17.5, and I've been given that probability. So X is now binomial. I've got 36 butterflies selected, and the probability that they're very large is 0.50527. What's the probability? 3 or more of those butterflies, so probability that X is greater than or equal to 3. So I'm looking at binomial CDF from 3 to 36, and the probability of being very large is that. So now I'm jumping into discrete binomial CDF, and the lower is 3, the upper is 36, the number of trials is 36, and the probability of success is 0.0527. So 294692, which to 4 decimal places becomes 0.2947. Okay, and lastly, the probability that n or more butterflies, probability that X is bigger than or equal to n, of a random sample of 36, very large, so it's the same as this, is less than 0.01. So I might do some trial and error. I know the probability that X bigger than or equal to 3 is equal to 2947. So I might go X bigger than or equal to 6. So I can come back up here and I can change that to 6. And that's 0.0106 less than. That's bigger than, so that's no good. Maybe it's actually bigger than or equal to 7. Go back up here and change that to 7. Oh, I don't like that mode, so I might change my mode to normal 2. Normal 2 doesn't have scientific notation. Uh, 0.02, so that's lower than 1%. Therefore, n equals 7 is the smallest value. because anything 7 or bigger, the probability is less than 1%, whereas if it's 6 or smaller, it's bigger than 1%. So that's question 4.